One of the things we often do with sequences, which we learned about in the last video, is to add their elements together or multiply them together. This video is going to demonstrate some mathematical notation for writing sums and products in a compact and efficient way. First, realize that when we say add or multiply the elements of a sequence, we don't necessarily mean all the elements. Sequences are infinite, and it's a tricky question as to whether it even makes sense to add up infinitely many things. That's a question that requires ideas from calculus to answer. So for us, when we speak of adding or multiplying terms of a sequence, we mean a partial sum or a partial product, starting at a certain point in the sequence, usually the beginning, and adding up or multiplying together the first n elements of a sequence. For example, in the sequence given by f of n equals 2 to the nth, where n starts at 0, here's the sum of the first 5 terms and the product of the first 5 terms, called the fifth partial sum and the fifth partial product, respectively. To write the sum of a sequence called A, starting at index 1 and going through index n, we write this. The big symbol here is a giant Greek capital letter sigma, which starts with S to remind you of sums. You read this as the sum of A sub k from k equals 1 to k equals n. This means A1 plus A2 plus A3 plus A4 and so on through AN. We can change a lot in this sigma notation. For example, the name of the index is irrelevant. We can also start the summing in a different place or end it in a different place or both. For example, here's the sum of 2 to the I power, where I goes from 0 through 4 as we saw above. And here's the sum of 2 to the k, where k goes from 3 to 8. Notice it doesn't really matter what I call the index as long as it's the same variable used inside the sigma. It's just a counting variable like you would use in a for loop. Also, there's no rule saying the counter must start at 0 or 1. In fact, sigma notation is really just a mathematical way of writing a for loop with an accumulating variable that we change by adding. For example, this sigma notation adds up the expression n times n plus 1 over 2 from n equals 0 to 10. Here's the corresponding for loop in Python that does the same thing. And you can also do this with a list comprehension by generating a list of the terms in the sequence and then using the sum command to add them up. We can also multiply sequence elements together, and we'd use a giant Greek letter pi for that. So this notation means take the elements of sequence A from 0 through n and multiply them together. For example, the product of k squared from k equals 1 to 8 is this number. Notice that if we look at the product of just the variable k from 1 through n, this is 1 times 2 times 3 times and so on up through n minus 1 times n, and that's n factorial. Just as sigma notation is math shorthand for a for loop that accumulates by adding, pi notation is shorthand for a for loop that's accumulating by multiplying. For example, this product is equivalent to this for loop. So in this video, you learn the sigma notation shorthand for adding up a finite partial sum of a sequence and pi notation for multiplying a partial product of a sequence. This shorthand helps us think and write about mathematical ideas that are coming up later.